what are these SMD devices? Surface mount means that these ICs and stuff are placed onto the PCB, and it's soldered on these PCBs. Okay, what are the through-hole devices? What we usually find are the parts with some leads, whatever. The main goal is with through-hole devices that we have the component, we have leads, and we put these leads into holes. That's where the name through-hole part comes, or through-hole component. A machine, some guy, or some assembly tool, whatever, places the devices into these holes, then it's soldered in place. So soldering does two things. First of all, it makes electric contact. That's the basic idea. The second is it provides mechanical contact to stuff. So for example, if you take something, it won't come off easily. So you can shake it, throw it, put it wherever you want. It won't fall off. That's the main goal of soldering. But what's the problem with the through-hole devices? First, we already saw that we have to position these pretty carefully. The leads can bend easily. It's not an easy job to populate PCBs with this kind of stuff. So it's really it can be really problematic in the industry. Okay, we have big through-hole devices, and these are soldered every day in the industry, but what's the advantage of surface mounting? So when we get a component and just place wherever we want, it took much less time. So much less time that when an automated so-called pick and place machine just comes, picks one of the components, the need components, from a tray or somewhere else where it gets from the feed. It places on the PCB, and the next comes, and they work pretty fast. So just look up how fast they can work. But we only placed this stuff at this time, so what's the really big deal? When we automate this whole process, it becomes much faster, easier to manufacture in the industry. Of course, when we make home PCBs like this Uno programming shield, or when we have to do a very fast job, and I know it's pretty disgusting. But it had to be done in a few hours in the afternoon. So when a pretty fast job comes, it's easy. Or why the hobbyists don't really use SMDs still after all those decades? Because it's that much to use a through-hole device in a breadboard. So if you do prototyping at home, it's still faster to do stuff, but these are all exceptions in the industry. So these are so low volumes that you only make one or two of these. So in these cases, SMD is not always faster to do, but if you do production, then it becomes much easier to understand why we use this. And first I want to encourage everyone to try to switch to SMD devices. And how to switch? Well, buy one of these cheap kits. It's under $1 or something like that. First of all, you can practice, and I try to show it. Just a second. You can have pretty tiny components, and these are not the tiny ones. These are just 0.8, 0.5, about maybe. But these proto boards or SMD tutorial boards go down to really, really, really tiny parts. And by tiny, I mean this tiny. Here's the tip of a tweezer. It's not really big. It's hard to pick up. So at first switching to SMD is intimidating because it looks really hard. All those parts are really small. I can't really solder them. Yes, when you start soldering, it will look like this, and sorry, this will be disgusting. So anyone watching these jobs would say that this is a mess. This was my first try doing SMD, about the first time. And the second one wasn't really much better. It's still disgusting. But after you solder all these little ones, you will get practice. It will be much easier. And I will try to show some tricks how to make it much easier to work with SMD parts. So at the end, you can easily design and manufacture stuff so small. Those are maybe 06, 03 components, if I remember correctly. So these are my main sizes what I use in most of my new designs. This is what I'm comfortable with everyday tasks. There are exceptions where you have to use bigger ones for capacitors or diodes or something like that. But first, let's try soldering. I will show some tricks, and yeah, I think we should start with the tools what we should have. So first of all, you will have your soldering iron at home, so you don't have to buy new stuff. That's one thing. The other thing is that yes, you can have a soldering iron, but try to forget the big bulky tips, because it's for advanced users, I would say, to solder multiple LEDs, and you should start with one by one, but hey, that's where we start. So let's go first with the 1206 parts. Preheat your soldering iron. Of course, you will have to clean and all the necessary stuff. And before we start soldering, of course, it must be clean and all. But let's talk about the solder itself. So, of course, get some quality one. But second, what I found good is this about 0.5 millimeter diameter, really thin one, because it's much easier to apply just enough of it. So you won't make those huge solder balls like I did at my first and second, and maybe about the 100th time too, but hey, that's life. So when this gets hot enough, it's already getting hot, let's talk about placing those little parts. So placing them is never done by hand. That's not only a no-no because of ESD, but it will be hard to pick up stuff. So either get some tweezers, or I made a little cheap vacuum pump. And of course it will be loud, sorry. But you can pick and place bigger components easily. The setting is it will just suck in the smaller parts, but that's life. So what comes after we prepared, and by prepare I mean let's get a new one. Let's get the components, and probably these resistors are meant for the 1206. So hopefully yes. So get a few of these components. And where to start? So if I place one on the board, of course tweezers can get sticky. So if I place first, try to solder, you can already see that it's moving because the liquid pulls the component. What we can have at the end, when we are unlucky, it's not happening yet, that it will just stand up like this, like a little tombstone. This tombstoning effect is pretty annoying because then you have to somehow put it back, and of course, since I heated it too long, this solder joint is just a wreck, but we will correct this pretty fast. So what I learned is to pre-solder one joint, place the component firmly, solder, it seems it cooled, and then you can do the other side. So if you are fast, it won't get overheated. So if we heat some component way too long, it may transfer too much heat, and voila, we get another error. So don't apply too much heat first. Try to apply some solder, not too much. Heat again, placed nice. And then the other side, do it fast. I hope it looks much better now. And still not the best solder jobs I made in my life, but of course it's always worse for the camera. Second, if we get all the devices, all the components we need, and want to have some speed, pre-solder the pads in batch, place the components in batch, solder them in place, and then solder the other side too. So this will speed up the process. It will become really fast. But that's only one point. The other one is these are just components with 2 LEDs. What about these ICs, like the 555, or just these little transistors with 3 LEDs? Those are more than 2, so how do we solder them? With these SO23 ones, we have an easy job. Let's prepare all 4 of them. Of course, when we do batch soldering, find all the places where you want to put your components. In this case, one of the pads is much bigger because whoever designed the pad wanted to have one larger for the top and two smaller ones. So in this case, when we have a bigger pad, I would say it's easier to use those. So pre-solder some of them. SO23 is really easy because it's not really symmetric. Heat, place, release, and hope it's aligned. It's still not the best, but forgive me. Pick, heat, place, align while it's hot, release, and now it's pretty firm, but the other two contacts also need to be done. Still do it fast. 1, 2, 1, 2, and we check it under the microscope, and we will do the other two under the microscope. Well, it's not the best looking one still, but let's do this one under the microscope. So some ball for the component. So this was for a component that's not really big, don't have too many LEDs, but already this 555 has 8 LEDs. So how do we solder stuff like this easily? One of my friends taught me a trick. We won't do this pin by pin. One side will be done with the small tip, and the other side will be done now with the big tip. And by the way, I use about 400 degrees Celsius in this setup. So how do we solder small components with many LEDs? First, do one pin, pre-solder one pad, align and solder that in place, and I will put it grooved. So now we see that it's not lined the best way. We don't match here at all. What we can do now, that we can push it a little bit if it's not too bad, and I would say it's okay. So we can align the IC without breaking one of the LEDs that's keeping things in place. Of course we could realign this, but in this case we say it's okay. Solder one pin on the other side. Now it's not going anywhere. So let's go and solder pin by pin. No, not this time. This is why I use the thin wires. So if we have a clean tip first and just pull the hot iron with some solder through the pins, they would be soldered, but of course it's not gonna work at this point. So we already jumped to the correction part, sorry. Apply some flux, but we will do this later on again. So with hot iron and some flux, and if we don't use too much solder, we can just pull through the soldering iron and it will be okay. But now correct it pretty fast because it will be disgusting otherwise. Not the best, but go to the other side with the big tip. It's much bigger in this case. But because they are bigger, their surface is much bigger too. We can easily apply some solder on the tip and just whoosh, go through all them, and of course I messed it up again. Increase some surface tension, clean the tip, and with one pull it became much cleaner and better, and no shorts between the pads. So there are some tricks in hand soldering pads one by one, or batch soldering pins. That's the good part. The bad part is that these pads, these sizes are not that bad. We can with SMD you can get so-called BGA ones, where all the pins are below the integrated circuit, so you can't even reach them. And of course, when you have too many components, you don't want to solder them one by one. And this is where these fancy chemicals and stuff comes to place. So normally, and when I did this keyboard, and where did I put it? So when I made my keyboard, and so when I designed this keyboard, I ordered this metal sheet. It has holes, and surprisingly, not so surprisingly, and if I find the correct orientation, this will be USB diode, and this is the orientation. So if we place this sheet over this PCB design, then we will see that the little holes match the pads. In the industrial environment, people get solder paste like this. These are tiny lead balls, and by tiny we mean some tens of micrometers in diameter, in some flux and other goo. And this paste can be applied on these masks. And by classic mask manufacturing processes, you just have some paste on the sheet, apply the paste on where you want. It will push just enough solder in these little holes. The amount of solder is done by the size of the hole and the thickness of the sheet. And then when we have this pre-soldered, and by pre-soldered I mean it's not heated yet, and we put all these components on this solder paste, then we can bake all this stuff in one of these little ovens. So these heating ovens, you put the PCB in there. Start it, you have to select the program how you want to bake them, and when it's finished you get back your hopefully done PCB, nicely done PCB. I had some issues with this model, but well, who doesn't have issues? So, but in not every case, so we don't want to buy or make or order one of these fancy sheets. Then these syringe applicable ones come to play. So we don't always have to do stuff with soldering iron. We can apply this goo on the pads when it's working. For example, in these 4 pads. We select the component we want to place there, probably these capacitors. Alignment is not a big deal because surface tension will pull the stuff in place. And at the end, do we get our soldering iron and heat all the stuff? It would work, and it seems to work, because if you apply heat and once do it zoomed in, so if we apply heat, this gray goo will shine much more like the solder we know. It melts, the other chemicals vaporize, and tada, we have our beautifully soldered little component. But we usually choose either hot air to solder these in batch, or get a hot plate like this. This is an open source one, and of course you will need some standoffs to place it on. So after you assembled all the components, you put it on the little baking board, your little oven. You program how do you want to bake it, and it will heat all the components and solder in no time, just a few minutes. So it's your decision. Of course, I would say buy a big soldering oven, but it's not for everyone. Hand soldering pin by pin with the classic method is eventually okay for many cases. So we already saw some bad solders, and let's redo them again. What we usually mess up with soldering is one of these tombstoning stuff when you apply solder on one side and the surface tension pulls up the stuff. This also can happen with this paste-based soldering stuff, so it's annoying, but it's there. Physics works. What can happen is that all the necessary good chemicals that make beautiful solder joints vaporize. You can apply some flux. I have dispensered one. I have rosin in alcohol. Both of them work. The synthetic one is better in one way. It in theory doesn't doesn't need cleanup in most cases, but believe me, it will need. So if you apply some flux, the solder joint will look better, but in this case we see that we applied way too much solder here. So how much is enough? If we check under the microscope, just a tiny amount is usually enough. So it's okay to apply just a tiny bit of solder, and by the tiny bit I mean preheat it. It already has some solder on because there is some residue on the tip, but really just a tiny amount is needed. Preheat the pad and poof. You only need some solder on the surface itself. Why? Because the method I showed last time, if you have a too huge little mountain of solder ball like here, it's a freshly made huge solder ball. First of all, it pulls this little spike on both sides, and that will have to be corrected. Much better. But first of all, it's not needed. It's unnecessary too much solder. The bigger problem is that if you try to put your component on a solder ball mountain, if I can grab this, then it will slip off. Of course, it doesn't really matter as if it has an angle, but if I push it down, solder it, it gets soldered, but what we get is a little gap because our tweezer slipped. So apply just a tiny amount of solder. I try to get another one. And first try to preheat the solder pad and the solder itself. And it will make much better joints. Of course, it has probably enough solder on this side. Some electrical guys who do soldering 24/7 would say that maybe applying some more is needed. Maybe it's not concave anymore, so it's probably now worse. But don't really apply too much solder. It's not gonna make the soldering easier or better. It's just wasting your time and solder itself. What we can have also, what I showed you previously, adding too much solder. How to remove all this excess solder? So first, when the surface tension goes well, you can pull this solder. So I will bridge all the pads. And if everything goes well, just pulling them will help a bit. So we didn't remove the solder itself, all of them, but we pulled where we want it to be. The other thing is that the tip also likes to pick up solder. So if we try to scoop, it may work if it's not too much. But this is where the magical chemical stuff comes into place. So these flux pastes do two or more things. First, they increase surface tension. So when I let's make a huge burned out mess, and if we pull, it's still not burnt enough. Finally. So we can make not so tiny spikes made of solder. And first of all, these chemicals increase surface tension of the solder, so they will become cute little balls. And of course now they attach much better to the tip of the soldering iron, meaning if we apply, and we can apply a lot of this, because you can wash it away with alcohol. So if we dunk our bridged pins with flux, we can pull a hot iron several times through here, and some of the excess solder will grab onto the tip. Now it's only a small ball, but most of the solder will move where we move our big ball of liquid molten solder. So that's one of the main goals of using flux. The second, it in theory cleans the pad a little bit. It's maybe acidic, if I remember correctly. So it takes away all the oxidation what happens inevitably on the pads themselves. So what can we do? What still have to correct with these? And yes, of course, when we have the soldering wick, this can these copper mesh stuff tends to pick up excess solder too. So we can apply these, and we have nice little solder balls here. So we will remove the excess solder by heating this, and I will clip some of it. And I prefer to use the big iron with much more heat. So if we push, and we can even pull, so we push down and pull the soldering wick, it will melt the solder joints below. The copper picks up the solder, and we successfully removed most of the solder, not 100%. So you can see that here is some left, but let's compare the unwicked and the wicked pads. It can be seen by your eyes too. So what components to select for your jobs after we have seen all these things? So when people start SMDing, they usually get afraid of okay, what can I solder? Of course we answered it. Get a practice board, get comfortable with the biggest components, and try to go to lower and lower ones. I'm currently comfortable with 0603 components, But if I have to deal with 0201, I can do it, but I work much faster with 0603 components. That's the current state. It will change hopefully over time. And what can be done is getting the pad size of the common pads. So we have SO8 here, we have this SOT 23 components. These are pretty common in size. So if you start designing a new PCB, know your limits. So when I started this, I knew I can solder these easily, but it didn't really need too many components, so it's not a big deal. The new PCBs I make, I have a little list of components. That's my limit, and using that I can select the components I safely use for my new designs. So I don't do BGA yet, I don't do two tiny pads. I did once this mini display port connector that was really tight. It had many pins. It was done with lots of flux, for example, and not for many boards. Only 2 or 3 were made. So when you get these little through hole demo kits, they are lovely because it's really good for kids to start with. But if you are doing this hobby a bit more seriously, then you can easily switch to these SMD parts. You don't really need resistors this big, and also I hate color codes. 472, that's 47 times 10 power 2. That's 47, 400, that's 4.7K. It's easier and faster to read the components than those color codes. And of course, capacitors, all of the stuff have the data there, but I prefer now doing everything SMD only, if it's possible. So for example, if you find only through hole battery connectors or stuff like that, many stuff will be through hole in the future too. For example, this transistor will be a dummy load for one of my projects, and if we have a dummy load, we have lots of power to dissipate somewhere. Where if we have SMD components where all the heat can only go to the PCB and the copper layer there, a through-hole component can easily dissipate all the heat at the backside. So it's not like only use SMD because it's the best. It depends on the application, the need, and the project. So don't trash SMD or don't trash the through-hole components, the old ones, because they are old. They are out. No, they are not outdated. They are used only in special cases nowadays. Okay, and when you go start doing SMD, yes, you can buy these huge little sheets for every of your project, but well, get some dispensers, and I tried more than one. This type is the worst, in my opinion. It's almost impossible to apply just enough of stuff. It's the worst. One better one was this type, where you push this, okay, this rubber band came off at this time, but don't care about this. So where you can apply this little metal part here, and it won't come off easily, and you can just twist this, and it can apply stuff much easier. But the problem is it's unintuitive for me, because this is how I would turn normally, and this is how it comes out. So it's maybe for lefties, but I don't know. It's not intuitive for me. This threading is not the best in my opinion, but still better than this little plunger one. The best I think is this type, where you have adjustable screw. You can also have 3D printed knobs, and you can adjust the length of this rod. So this is how it comes. You insert your little syringe here, close the lid, and push until, or rotate until it has a firm push on this little part here. Then you can have some grip. It's just more wonderful to work with, in my opinion. No sponsored stuff here, so that's my personal opinion on these parts. Of course, you can get cheap homemade pickup tools and expensive ones. That's not a must. Tweezers are a must. Soldering wicks are useful, but I don't use them really often. But what you should really get is a hotter soldering station. It's really a must for jobs like this, because you can easily heat all the PCB, all the parts almost at the same time. You can get really consistent results with this, and of course at the same time it's getting warm. This is the only tool that helps you desolder parts one by one by heating the component. I think I tried this under the microscope. So you can heat the part, and if it's get hot enough, you can remove the component. And it didn't really affect the other parts here. Of course, the solder got molten here too, probably, but that didn't really give us too much problem here. You can get these homemade or store or factory made hot plates. I didn't really use them yet, but they look useful. And after we finished cooling the little hot air gun, let's talk about designing and going back to selecting your parts. So that's obvious. Always check the size of the parts. You can get fancy and cool little rulers with the hole diameters, components, little pads, and even some of them have pitches and trace widths like here, but they don't state how much amps can it handle. Some of them has some fancy info there. Thanks you, Mauser, for this. They didn't sponsor me. That now you can see here some of the BGA stuff. So good luck soldering that without hot air or oven, or without hot plate. But one thing to design or one thing to consider when doing design, and we will finish this. When we look at our little motherboard, one random PC part, we have a lot of components on one side and just a few of them on the other side, because that's where manufacturability comes in place. When you make PCBs for your for fun, then it's okay if you solder both sides by hand, each part pin by pin. But if you really need to hurry and manufacture hundreds of them, like I have to do with these little lights, then it's a must to consider manufacturability, and that's why in most cases components are only placed one side. Okay, through-hole components will be soldered on the other side, but consider this in the future. And I think that was all for today. Thanks for watching, and let's meet sometime in the future.